All right, moving right along here, our next section is going to talk about changes in matter. Going along with the idea of properties, we have physical and chemical properties. Well, we have two types of changes as well. We have physical changes and chemical changes. Physical changes are going to be alterations in form or appearance. Again, think about physical properties, use your senses to detect. So if it looks different, then it probably went through a physical change. But it does not make a new substance. So I'm not taking apart chemical bonds. I am not rearranging chemical bonds. I am just changing the way you perceive this same substance. As opposed to a chemical change where I will be taking apart these chemical bonds, I will be making new substances, and that is going to be your telltale sign that, hey, you just witnessed a chemical change, is the fact that you have different substance than you started with. So let's start with physical changes. Physical changes are going to undergo any when a physical when a substance goes under a physical change, you're still going to have the same substance. For example, if you have a pencil, you decide to break your pencil in half, you still have a pencil. It's still the same chemical makeup. You didn't create a new substance. You just have a broken pencil. But still a pencil. If you take an axe to some wood, you're going to get some wood chips everywhere, but they're still wood. You didn't make a new substance yet. So therefore, you only went through physical changes. Other examples are like ripping a piece of paper, folding a piece of paper, crumpling a piece of paper. Uh, Anything that's going to keep the same substance after you're done, it just might look different. So bending something as well. There are plenty of different examples of that. For example, right? The big one we want to look at is the change in the state of matter. So is this substance changing from a solid to a liquid to a gas? That's a big one because it looks very different in each state. I mean, just look at water. You can see liquid water, it behaves one way. You can see ice, it behaves one way. And you can't even see water vapor. It's an invisible gas. So you can't even pick up on it. It doesn't smell like anything, it doesn't taste like anything. You can't even see it. But changes in state are going to be considered physical changes because just like that example with water, I still have H2O. It just looks different. It's still two hydrogens per one oxygen. It's still water. So these are all different examples. This little GIF you're seeing here is actually the sublimation of dry ice. I did it because you're actually seeing this fogginess is actually water. That's liquid water coming off of it. It's all the water vapor in the air just got so cold that it condensed into liquid water around the dry ice. Chemical changes, you are producing a new substance. Your properties will change with that new substance. Like we mentioned before, one chemical property was the ability to rust. Well, actually, rusting is a physical change. Here you are taking iron and you're exposing it to oxygen. It is rearranging the molecules in there. We are no longer having iron and oxygen separate. They are combining through a chemical bond, making a substance called iron oxide, which is what we call rust. So that is a chemical change. Again, your telltale sign is that you have a new substance. You took your original substance, you put it through a change, and now you have a new substance. Here's some other examples of chemical changes. Burning, pretty much anything. Burning and combustion kind of go hand in hand. Electrolysis, if I shoot electricity through something, if I give it a whole bunch of electrons, that tends to rip it apart. For example, if I decided to shoot a whole bunch of electricity through water, I would rip apart the hydrogen and oxygen, and I will get hydrogen gas, and I will get oxygen gas. Oxidation, again, that's rusting, is one type of oxidation that iron goes through to make iron oxide. And tarnishing, you probably have fancy silver somewhere in your house that needs polished every now and then because it does tarnish. One very, very important thing to note for changes, especially in chemical changes, is the conservation of mass. This is a scientific law. You cannot break it. You cannot come up with anything that is occurring in our universe that does not follow this rule. So it is very important to know that matter is not created or destroyed. The amount of stuff that I have in this world, again, matter is anything that has mass and takes up volume. So anything that is matter in this world I had from the start. I do not create more. I do not destroy it. I just rearrange these different elements, these different atoms to make different molecules or different substances. So looking at our equation for photosynthesis, which you should all be familiar with from last year, I just want to point out that one, it is balanced. So when it comes to photosynthesis here, I am taking carbon dioxide, I am exposing it to water, I am providing energy through light. This arrow means yield. It is going to yield sugar, which is glucose in this case, and oxygen, which is the waste product of your plant. That's what it gives off and you breathe in. If you take this backwards, that is respiration. That's what you go through. But I want you to pay close attention to the numbers right now to see that mass is conserved. Here we have carbon dioxide. Let's just focus on the carbon. Carbon is C. According to this, I have 6 carbon dioxide molecules. Each carbon dioxide molecule is 1 carbon and 2 oxygens. Well, I have 6 of them, so I have 6 carbons altogether. Hopefully you see that. Just playing with the numbers. I do not have any carbons over here. Over here I have sugar. 1 sugar molecule is using all 6 of those carbons. I don't have extra carbons. I don't have any in this oxygen over here. It is being used all here. I did not create carbon. I did not destroy carbon. I began with 6 carbon. I ended with 6 carbon. I just moved it from being attached to a carbon dioxide molecule to a glucose molecule through photosynthesis. So again, conservation of mass is extremely important. I do not lose things. I do not gain things. I cannot destroy. I cannot create. Just keep that in mind as we go throughout the rest of chemistry. There will be other laws of conservation, but they all pretty much mean the same thing. You cannot create things. You cannot destroy things.